Welcome back to my YouTube channel. So in this video, I want to talk about the Polars library. So it is a Python library that is used for analyzing data. So in most cases, you are normally familiar with the Pandas library, which is used in most cases. But as the data becomes too big, it becomes nearly impossible to analyze such data with Pandas. So that's why Polars was brought in. So it is a lightweight and a fast data frame library. It is built in Rust, but there's a Python API for it. So we are going to use it to analyze some large data set from flights data, which is a USA data of flights in the USA. So the data, I've already downloaded it, but if you want to see where it is from, you can. I'm going to put a link to the data set. So it's quite a big data set, about half GB. So I'm going to download it and analyze it with the Jupyter Notebook so that you can see the power of Polars. So let me activate a virtual environment. So I'm using Conda. Already have an environment called data analysis. So once it is activated, then we can open the Jupyter Lab, where we'll be doing the analysis. File Explorer. So I'm going to save it in a folder called YouTube, and in the Polars there's a data folder, and there's this flights.csv dataset. So we can create a new notebook here. So you can just call it. So in the flights notebook is where we'll be writing most of the code. So the first thing first is always to import the libraries we are going to use. So the first one we are going to use is the Polars. So if it is not installed, then you'll have to do the pip install Polars. But for my case, I've already installed it. I just need to import it. Then we can give an alias of PL. The next thing we are going to use is another library, which is integrating Polars with Pandas. So it's called PyArrow. So we are going to import that. If you don't have it installed, then you can do a pip install PyArrow. I give it an alias of PA. Then for visualization, I like using the Plotly. So we are going to import it. So we are importing the Express version. So once the libraries are imported, then we can load the dataset. So we can set up a file path. So for my case, it is in the data folder. So if I can copy the path, then we can create a data frame to hold for the. So we're going to use the scan CSV method of the Polars library, and we pass in the file path. Then we can review it with the data frame.collect. So this is the data set. So there are about 581, like 5 million records, rows, and 31 columns. The next thing we need to do is now like do some filter, because we can't analyze all these columns. We need to filter them to some basic ones we are going to use. So if you want to see what the columns represent, then if you check in the Kaggle data set for flights, there's these columns which represent what they mean. Like for the example, year is just a year of the flight trip. So there are about 31 columns, but the ones which are key to us are these ones. So we can select them. So the first one is the flight number. We also need the month, the day, the airline, origin airport, the destination airport, whether the flight was cancelled, is a boolean, whether it was diverted, then what was the scheduled departure, then the actual departure time, then there's the departure delay, which is just the difference between the two, departure time and the scheduled departure. We call it departure delay. Then there's the scheduled arrival, then the actual arrival time, and the arrival delay. So we are going to use this one to show some performance metrics of the airlines based on their arrivals, delays, and the departure delays, and also what's like the percentage of flights which are on time. So there's the select method for the Polars data frame. So we just pass in a list of columns to filter. So once that is done, then we now have like a subset of columns we are interested in. The next thing we need to do is to, if you check on these times, like they are in integer format. For example, departure time 23:54. So this is a time which is like 11 p.m. and 54 minutes. So we need a way to convert these ones into a time data type so that we are able to analyze them in, like, for time series analysis or any analysis which require them to be in time. So we need to create some new columns which will just convert these ones to appropriate data types. So the first one we are going to create is the schedule departure time. So to do this, we are going to use the with column. With the column is a method of the polars which just create new columns. Then you pass in some, maybe some regular expressions if you want to get the data from another column. We are going to use that. So we call the data frame dot with the columns. So the polars dot call, which is a method to create a new column. So we're going to call it schedule departure. So then we apply. So for here we're going to apply just a lambda expression, the digits on the first and the, so this second, the first two digits will represent the hour. So we can create like an alias for this as hour. So this will create a new column called hour, and we're going to use it when we are combining them to create like a date time. So let me just show you what I mean by that. If you run this, so there will be a new column created which is called hour. So this is what we are going to use to combine them when we are creating the date time for the scheduled departure. Then we can also get the minute. So you can do a with column. So it's just going to be like this one, but the only difference is where we are going to get the integers. So we can just copy this. So instead of looking at the, we're going to look at the last from second index to the last to represent the minute. So if you now display, we have created another column called minute, which is also derived from the scheduled departure. So from index 2 up to not up to the last one, we are going to get the integers and put it into the new column minutes. So the next one we are going to look at is now how to combine these ones into a date time, so that we can have like a scheduled departure date time data type. So we're going to do another with. So for this case, we are going to create a date time field. So we call the polars date time method. Then you pass in like now the strings we want to, the columns we want to check or to combine. So for the first one will be the year, then the month, the day, the hour, and the minute. So this one, if you combine all those strings, it will be a date time. We can now create an alias for it. We can call it schedule departure date time. So if you run this, so you will see another new column now, which is a date time field created. So this is what will be important for us, as we are able to use it for time series analysis. So we are going to repeat this for 3 other columns: the arrival, date time, and the arrival and the departure. Remember, these are schedule and there's also the actuals. So let me just copy these. So we can create schedule arrival time. So the column we're going to look after is the schedule arrival. So we are going to do the same things: year, month, then the name we can give it as schedule arrival date time. Can we rename this to arrival, so that when we run this again, it will create this new column, which is the schedule arrival date time. The next column we can create is the actual departure date time. We can also copy this one, we can paste it here. We can call it create actual departure time. So we are going to refer to a column called departure time. So we apply the same things. Instead of calling it schedule departure time, we just call it departure date time. Then you can do the same with the actual arrival also. So we are referring to a column called arrival time. Then you can rename it as arrival date time. Everything remains. You can now do a display, just the changes. Yeah, so they have been created. So the next thing we're going to do is like remove these ones we created in these new columns, like the H for the hour. So we don't need them for the analysis. So we can filter out again by calling we put a list of columns we want to include in our data frame. So we need flight number, we also need the airline, we need the origin airport, we need the destination airport, then we also need the scheduled departure date time. Remember, this is the derived column. We also need the departure date time, which is the actual departure. We do the same for, there's also the departure delay, which is the time in minutes the flight delayed to depart. Then schedule arrival, can add also that one, date time. Then we can also do arrival date time and the arrival delay. So the last ones are those two Boolean fields like cancelled, whether it was cancelled or diverted. This should be enough for our analysis. Then we can just filter it through by selecting only these columns. We can do a display. So it looks pretty good. 12 columns, 5 million rows. So the next thing we can now do, like start some analysis. The first one we want to check is the departure delays per airline, or what, like the number of departures which are delayed. So for this, we are going to use a query which is going to check on the number of the mean departure delays for a given airline. So we take all the number of departure delays, we get the mean, so we can get on an average how long does the airline delay in their departure. So for us to write the query, we are going to can create a new variable q. So we are going to pass in some parameters. So the first one is the data frame. The second one is we do a lazy execution, meaning the query is only is going to be executed once. When we do a group by, pass in the column you want to group by. For this case, we are going to group by airline. Then we do aggregation. So we are going to do a mean aggregation. So for the aggregation method, we are going to pass in the column. So we call the polars.call, pass in the name of the column. For this case, we are interested in the departure delay. Then aggregation method is the mean. Then we can give an alias for this column and just call it as depart delay. Once we do the aggregation, maybe if you want to sort the data, you can also call the sort method. You pass in the by, which is the column you want to sort by. You can sort by departure delays. If you want it in descending order, we can set the reverse to be true. We can now execute the query, then display the result. So there's a syntax error on the, we don't need to call this one. Well, the lazy is done on the data frame. So we have now like each airline and the average or the mean departure delays in minutes. So the next thing we can do is to visualize this on a bar chart. So we are going to use the Plotly Express. So we can call the Plotly Express library and we call the bar method. So here we're going to pass in a list of arguments. So the first one is the data frame we want to visualize. So how did we name it? DF delays. You can convert it to a pandas data frame, which is always easier to work with in Plotly. So x-axis, the airline. Y-axis, you can set it to be the departure delay. Title, you can set it to be the average departure delays per airline. Then for the labels, we can pass in, for the labels for the y-axis, you can pass in a dictionary with the key being the column name airline. We can rename it to just airline, but like that. Then for the departure delay, we can rename it to just delay in minutes. So since the departure is already in the title, we don't have to repeat that. We can do a visualization of this. Yeah. So these are the average departure delays per airline. So the one which is having a higher delay is this NK, airline code NK. So we can check the airlines, what NK means. The Spirit Airlines. So Spirit Airlines seems to be the one having a considerably high delays in their departure times, followed by the UA Airlines. So UA Airlines, if you check on the dictionary, United Airlines. So you can download this and put it if you're doing a report. There are some things you can do a lot in customizing. So you can check on the Plotly documentation to just see how you can most customization you can do on the plot. We can also do the same with the arrival delays. So you can create a new. So it's just going to be the same code, but we are going to change the data input. So we need to do another query instead of checking that departure delay. We want to check out the arrival delays. So instead of this one, just change this to arrival delay. So we can rename it to arrival delay. Then we sort by this arrival delays. We can rename it as arrivals delay. You can do a display of that. So this is the data which represent on average how many minutes the airline like delays in arrival at the destination airport. So we can also visualize this. And just copy this visualization and just change some few things. So the input data frame, we can pass in the arrival delays. Airline, it's okay. We need this one as our y-axis. We can rename it as average arrival delays per airline. Then we can change these labels for the axes. Then you can just plot them. So NK seems to be the one arriving mostly late, a delay of average 14 minutes. So NK is Spirit Airlines. Then F9 is Frontier Airlines. So those ones are the ones normally arriving late, with NK arriving late mostly on average 14 minutes and NK 12. Then the next metrics you can check is the on-time performance. On-time performance is just like a percentage of all the flights which arrive on time versus all the total flights. So most countries have a given like time frame which they use to judge whether a flight is delayed or on time. So if it is within 14 minutes, for example, in the US, then it is considered to be on time. Above 14 minutes, then it is considered to be delayed. So we can do that. We can start with the on-time departures, the ones which depart on time as scheduled. So we can create a copy of the data frame and have it in pandas. Just make it easier to use the visualization tools, because Polars does not support visualization natively. So we can do that. Then, like I said, we can set a time frame which is accepted by a given country. For example, in the US, it's 14 minutes. Then we can create given a new column which is like a boolean to check whether our given flight was on time or delayed departure. So we can create a column called on time, and we're going to derive it values from the departure delay. We're going to check if the departure delay is less or equal to the time window, which is 14. Then it is going to be true, otherwise it will be false. So if you execute this, and we just have a preview of how the data frame now looks like. This is pandas, we can just go ahead. So there's this new boolean field added, which is representing true or false. If it meets this condition of being less than or equal to 14 minutes, then it's true. It came on time. So the next thing we can also check is now the rate. What is the total number of flights which are on time? So for that, we can create a new variable called on time departure, maybe rates. So we call in the data frame. The column we are interested in is the on time. So we just want to create the mean on this column with aggregation. You can multiply by 100 to change it into percentage. Then you can do a print to just see that in the United States, what is the average flights which depart on time, the percentage of flights which depart on time. 80% of flights in the US depart on time. That's pretty good. We can also do the analysis by airline. So just see which airlines are performing best based on the on-time departure percentages. So for that, we need to do a group by airlines. So we can create a new data frame. We can call it grouped. We can call the initial data frame, this the data frame pandas. Then you call the group by method. You pass in the column you want to group by. For this case, we are grouping by airline. So with us, we can now calculate performance for the group by. So to do that, we can call on time depart rates as a new variable. Then we pass in the grouped data. The column we are passing for grouping by is airline. We do a mean, the aggregation method. You can multiply by 100. Then you can print the on-time departure rates for each airline. So it will do a group by of airlines, then do a mean of all those ones which departed on time. So to calculate the on-time performance departure for airlines, we need to group the data by airline. So we can create a new data frame, call it grouped. So we call the initial data frame, which was data frame pandas. Then we do a group by, we pass in airline as the column we want to group by. So from there, then we can now calculate the performance rate. You can just call it on time depart rates. So we are going to call in the group. The column we are interested in is on time, then the mean multiply by 100. Then you can do just a print of these. So you can also do like a sorted one. So you can sort the data so that you can see it unsorted. We can call the sort values method. Ascending order. You can set it to false so that it sorts them in descending order. You can see now who is the one performing. HA Airlines. So 92% of their departures are on time. So we can check the code for that. Hawaiian Airlines seems like they're performing well, followed by AS. AS is the Alaska Airlines. So their departure, if you check the percentage of flights which are on time, departed on time, 92%, and the other one is 88. Which is pretty good. So remember, we are using the standard for US, which is about 14 minutes. If a flight departs within 14 minutes of schedule, then it is on time. We can now create a bar chart for this to just visualize it. So we can call fig Plotly Express, call on the bar chart method. So the first one we need is the data frame. For the x-axis, we can call the index. So this will be our x-axis. Can call in the index property of this. Then for the y-axis, we are going to call the values property of this series. So this is a series. Then for title, you can call it on time, maybe departure performance by airline. For the labels for the y-axis and x-axis, we can pass in a dictionary with the values, key value pair. To show the plot, you can just call the fig.show. Indentation issue at so this is the chart. We can do the same with also the arrival performance, on time arrivals, so that you can see which airlines generally arrives on time based on their percentage of arrivals. So we can just create a new markdown here. It's just going to be similar with this one. So we need the window time is 14 minutes, but our new on time column is going to pick data from arrival delay. Then we can calculate the overall on time arrival delay arrivals. So we can also just copy this calculation. We can rename it as on time arrival rates. Can preview it. 79% of the flights in the US generally arrive on time. And arrival on time means they arrive within the 14 minutes time window. Then we can group the data if you want to now do by airline. So we can create a group which is taking the data from. Once we group the data, then we can calculate the performances. So for this case, we are going to call in, we can create a new variable, call in the grouped data, then on time, we get the mean, we can multiply by 100 to get the percentages, and you can print it. So we have to call the method on the grouped. So we group by airline, then we pass in the on time to calculate the rates. So if we now print the on time arrival rates, it will give you that. Then we can now plot it. So to plot it, we can use the same code we used here. So before we plot it, you can also even sort it out. So we can call the sorted on these rates. We just need to call the sort values ascending false. So we have a sorted data frame. So we pass that. This is okay. On time arrival, performance, arrive on time. Then you can show it. So the first is still Hawaii Airlines. It's followed by the AS, which is the Alaska Airlines. So they generally arrive on time, 88%. So they departed 92% of the time, and they arrived on time 88%. Seems like a good airline. So there are a lot of things you can do. You can even do a time series analysis of like how the American airline or transportation industry has been performing based on like arrival delays over time. So you can do a line chart of that. You can just call it the average arrival delays if there's some improvement. So you can just create a copy of the data frame. And then because we're dealing with time series, we need to have an index set as date time. So you can choose the data frame that set index. So our index must be a date time field, which in our case is the arrival date time. We want to do it in place. We don't want to create a new data frame for that. Then we can call it. So if you now do a df.head preview the data frame, you'll see that now the index is set to be a date time field. And since you want to check on a daily basis, we can resample the data to be grouped by day. For that, we are going to call it maybe daily delays. For that, we are going to call the data frame arrival delay, and we can call it resample. We want to resample it on a daily basis, so you can pass in D. And we want to get the daily mean. We can do a display of this. Just see how the data is now resampled. So we have now on a daily basis and the average delay, arrival delay. Then what we now need to do is just plot this on a line chart. So to plot that, we are going to need the px.line method. So remember, we are using Plotly Express, which we had set alias as an alias of px. Call in the line method, then we can pass in the first is the series, which is the daily delay. Then we pass in the x-axis, which is going to be from the index property of the daily delays, these ones. Then we can pass the y-axis, which is the values, these ones, the daily delays series dot maybe values. Then we can now show it here on the console dot show. So this is how it has been. This is from January 2015 to around December. So it's pretty much seasonal. So there's times when it is really low, but also peaks at some time, like in March, some high peaks in August and DEC. This now investigation starts to follow up on those months on why the steady rise on the delays during such months. Could be people are going on vacation. We can also do with the same with the departure delays. So we just need to change this to departure, daily departure delays. So we just need to call it, we resample it by departure delay. Once we have the series, we can preview it. We only need to now put it on a plot. We call in the departure delay series. X-axis is from the index, which is the days. Y-axis the values. Pretty much similar graph. So there are a lot of things you can do with the Polars data frame. So if you check on the user guide, there are some methods I've not touched in this tutorial, but they are pretty much cool, and you are taking advantage of the multi-threading nature of the execution of the queries, so making it much faster than pandas. If you had to do the same thing with pandas from the data cleaning stages, then it will freeze on my low budget machine. So that's why it is always good to either use Polars, or if you can use also the Apache Spark, which is another nice big data analysis tool. So there's a Python library for Apache Spark, the PySpark, which helps you to achieve the same thing Polars does. Yeah, but you can play with it, and if you have any question, leave it in the comment section so we can figure it out. Thank you and have a nice time.